According to the widely accepted theory, approximately 13 and 8 billion years ago, a Big Bang occurred that gave rise to everything we know now. It is believed that at that moment our entire universe was born, which subsequently formed into what we see today. However, before the Big Bang, there may have been nothing or something that we cannot even imagine. We will try to understand what was before the Big Bang. The Big Bang is a widely accepted cosmological model that describes the early development of the universe, beginning with the expansion of the universe, which was in a singular state before that. As for this singular state, it is sometimes characterized as a cosmological singularity. It was the state of the universe at the initial moment of the Big Bang, which was characterized by infinite density and temperature of matter. To understand what happened before the Big Bang, we turn to some theories that directly relate to the explosion itself. According to one of them, at the moment of the Big Bang, the universe could have been extremely small. It could literally have been a tiny point. Some scientists believe that everything we have in the observed universe today, this sphere with a diameter of about 93 billion light years containing at least 2 trillion galaxies, was a tiny point. All today's galaxies were as if squeezed into a space smaller than centimeters in diameter. However, this is not the only version. According to another theory, the universe could already be infinitely huge beyond the observable universe. There may be much that we simply cannot see because it is physically impossible. Therefore, it is possible that the universe was tiny or infinitely large during the Big Bang, because there is no way to see what remains beyond our visibility. The essence is that space itself is expanding, so everything that was beyond the tiny point from which the universe was born will remain outside of our reach. Yet, what existed before the Big Bang is undoubtedly one of the most global questions that people have been searching for many years. In fact, there is no one answer, and probably cannot be one because we simply cannot fully understand it at present. Therefore, there are only various theories describing possible processes that occurred before the Big Bang. For example, Stephen Hawking believed that there was absolutely nothing before the Big Bang. He said that if we rewind time by 13.8 billion years, the entire universe would be represented by a single atom. According to his words, if the universe is expanding as we move forward in time, then if in theory we could reverse time, it would start to contract and compress, which should not be confused with technological singularity. Inside this very small, massively dense spot of heat and energy, the laws of physics and time as we know them cease to function. In other words, time, as we understand it, literally did not exist until the universe began to expand. There is also a completely opposite version, according to which, before the Big Bang, the universe was an infinite space made of dense material, which remained in a stable state until something disrupted it. When this dense space lost its stability, a big explosion happened, which was of a superdense universe. It was possibly controlled by quantum mechanics, and after the big explosion, classical physics became the main driver of the universe's evolution. This theory explains the existence of space before the big explosion, but what about time? According to one point of view, time did not exist before the big explosion, neither did space. However, in 2018, British cosmologists from Oxford University, led by Professor David Sloan, conducted calculations. The calculations showed that space and time did exist before the universe was born. David Sloan said, "We are not introducing any new concepts or changing the theory of relativity, just the interpretation of some of its postulates. Our calculations show that the Big Bang was not the beginning of time, but just a change in the orientation of space. In other words, it was space that broke, not physics." Elephant and his colleagues came to this conclusion while trying to find an answer to one of the most important questions in history, what the universe looked like in the first moment after the Big Bang and how it appeared before the cataclysm that gave rise to everything. Today, as scientists explain, there are two approaches to this problem. For example, cosmologists believe that the universe was born from a singularity that began to rapidly expand in the first moments after the Big Bang. However, astrophysicists believe that the birth of our universe was preceded by the death of a progenitor, which likely occurred as part of the so-called Big Bang. Either way, both of these versions are almost impossible to prove. If we turn to the first theory, the very existence of some form of spacetime before the Big Bang raises a multitude of almost insoluble questions. For example, it is not clear how this form could have given rise to an energetically pure and new modern universe. Another problem is that at present, cosmologists cannot even speculate about what this old world and old universe looked like. The issue is that the theory of relativity ceases to work at extremely high energies. The energies characteristic of the Big Bang and the singularity that created it have led scientists to debate what laws governed the universe's existence in the first moment of its new and final seconds of its old life, if it existed at all. Many cosmologists and astrophysicists, including the aforementioned Stephen Hawking, prefer to sidestep this question and do not assume that time did not exist before the Big Bang. Therefore, the problem is meaningless. However, David's team proposed a new interpretation of this mystery that resolves the question of the old universe's existence in an original way, without violating Einstein's postulates or introducing any new complex entities, such as strings or quantum loops. They focused on one simple thing: while inside the universe, we cannot precisely measure its dimensions and compare it to something beyond its boundaries. Therefore, all the quantities and phenomena described by the general theory of relativity and other cosmological theories are relative. The notes that this is a simple idea that allows scientists to circumvent practically all of the unsolvable problems associated with infinite energy density and the curvature of space, which cannot be explained within the framework of classical Einsteinian theory and the spacetime structures associated with it. Guided by this idea, scientists have built a computer model of a dimensionless universe and studied what the starting point of the Big Bang looks like. It turned out not to be a singularity but a different structure, which the elephant and his colleagues called the I-point, in contrast to the Big Bang's fabric of spacetime. The fabric of spacetime does not cease to exist after its birth, rather, it becomes mirrored. In other words, before its birth, as calculations by British researchers show, spacetime simply becomes mirror-like. In other words, before the birth of the universe, time flowed in the opposite direction, and space was oriented and represented somewhat differently. According to scientists, these transformations do not contradict the theory of relativity and do not affect matter itself. Essentially, only the map of its distribution changes, not its internal content. The elephant's innovative theory explains not only the principles of the operation and existence of time and space before the Big Bang, but also the absence of antimatter in the universe, as well as some other peculiarities that scientists are currently debating. The next theory, the Big Bounce, partially resembles the previous one. The theory suggests that a small explosion, or rather a big bounce, contributed to the birth of the universe, caused by a peculiar interaction between the old and new universe a long time ago. In medieval India, some religious philosophers taught that the universe undergoes an infinite cycle of creation and destruction, developing from undifferentiated mass into a complex reality before destroying itself and starting over. Some modern scientists have arrived at this same idea with striking parallels, believing that instead of a Big Bang, the universe expands and contracts in a cycle, bouncing back each time it contracts to a certain size. The theory of the Big Bounce is partially similar to the previous one. According to the theory of the Big Bounce, each cycle starts with a universe that is not as small and smooth as the singularity. It gradually expands and becomes lumpy and deformed over time. Eventually, it reaches a point where it begins to break down and gradually smooths out, decreasing in size until it reaches its initial point. In this way, the Big Bang is like the beginning of the expansion of a new universe. Specifically, it is an explosion of singularity from nothing. In other words, the Big Bounce theory suggests that our universe is constantly being refreshed by these cycles. This means that before everything appeared, there was simply another universe that had reached the final stage of its cycle and had compressed to its original size, giving birth to the new universe that we can see in the observable universe. In any case, whether it was a Big Bang or a Big Bounce, the question of what existed before our current universe remains open. None of the above theories is 100% accurate, they are all just theories. Perhaps one of them is correct, or perhaps they are all far from the truth. Maybe there was nothing before the Big Bang. Perhaps there was a whole universe, or even time and space, or maybe there existed an entire sea of universes, each with their own laws and physical properties. Perhaps we will never be able to answer the question of what existed before the Big Bang. It is likely one of those questions that has no answer, at least not yet. However, it is not impossible that in the future, science will advance to such an extent that it will be able to answer this question and provide a complete picture of what happened before the beginning of the universe. It is also possible that future generations of scientists will delve even deeper into this topic and find answers to even more complex metaphysical questions. For now, each of us can only speculate and choose the versions that resonate with us. Please leave your thoughts in the comments section and if you found this interesting.
From the drama of our planet's origins and the birth of our solar system comes one of the most startling revelations of modern science. The solar system we see today, quiet, stable, was once a battlefield. Newborn planets blasted through space, competing for stable, circularized orbits inside a grunge-style mosh pit of gas and dust. For those that find the right balance, the prize is survival. For the rest, world-shattering destruction. A new look at the chaos of creation and a frightening possibility in our distant future. Mars. The Curiosity rover is searching for clues about the origins of the red planet. It confirms the presence of oxygen and nitrogen isotopes hidden in the rocks and soil.
We use isotopes to try to figure out the history of planets, partly because they are immune to many of the changes, the chemical changes that occur when you have things like collisions and so forth. Isotopes, the relative abundances of these isotopes are like fingerprints.
Curiosity confirms a unique mix of isotope fingerprints. The isotopes indicate that Mars formed elsewhere in the solar system and moved into our neighborhood. Our solar system is full of oddities pointing to an imperfect birth and a malformed evolution. All of our planets go around the sun in the same direction that the sun is spinning. This is the same direction that the clouds within our original nebula began to rotate. 6 planets spin around their poles in the same direction. For them, the sun rises in the east and sets in the west. Yet 2 planets spin the opposite direction. For Venus and Uranus, the sun rises in the west and sets in the east. Uranus not only has a retrograde spin, it rolls on its side like a bowling ball. At Neptune, the icy moon Triton, orbits backwards, opposite from the direction of Neptune's spin. Do these planets spin backwards because they were rocked by titanic collisions in the past?
So we see evidence in the architecture of the solar system for not only collisions like Earth's moon and the fact that Venus is rotating in the wrong direction and Uranus is on its side and so forth. All these things are attributed to collisions. We also see in the asteroid belt and in the Kuiper belt, the outer asteroid belt if you like, we see that the orbits of these things look like they've been disturbed.
Closer to home, our own Earth has an inexplicable 23.5-degree tilt. Its spin axis is radically misaligned from its magnetic pole. And our moon is comparatively large for a planet our size. Now, a new theory may be able to explain many of these oddities. It is called the Grand Tack hypothesis. Four and a half to 5 billion years ago, a gas giant planet arose inside a primordial disk of gas and dust.
Jupiter didn't just form where it is, but formed and then moved inward towards the sun.
As it spirals toward the sun, Jupiter herds asteroids and rubble.
Jupiter's natural tendency is to drift in slowly through this debris field that it's traveling around.
The inner solar system is also thick with gas and dust. The planetary system is well underway. Numerous worlds are born in this region, including the Earth. Primordial skies are ruled by chaos. Jupiter's approach destabilizes these planets. Their orbits decay into wildly swinging ellipses. Some are tossed out. Others fall into the sun. Their numbers are unknowable. These are ghost worlds from a bygone age.
Jupiter just causes all heck to break out in the solar system, and all that debris in the outer solar system gets flung inward towards the inner solar system.
And it was a busy time in the very early solar system, and things were colliding with each other all the time.
And then it stopped. Jupiter's invasion of the inner solar system is mysteriously halted. The planet makes a turn, or, in sailors' parlance, a grand tack. Lurking behind Jupiter is a second gas giant, Saturn.
So as Jupiter was migrating inward, Saturn was following it and growing. And as Saturn was growing, it came to have a size that it had a gravitational impact on Jupiter, which became more important than the gravitational interaction between the gaseous disk and Jupiter. They reverse direction. And in a sense, you can think of Saturn and Jupiter feeding off one another and moving back out.
Gravity tugs each passing planet.
Is exert a very subtle little periodic force at the right time, and you can have amazing changes in the motion of the object you're pushing on.
Once enough energy has been transferred, the planets synchronize their orbits. They are said to be in a resonance. For planets, Resonances are achieved and maintained through the mutual push and pull of gravity through the fabric of space. They're a key factor in the continuing evolution of our solar system. This effect can be duplicated in the lab.
We have 10 metronomes here set up on a swinging platform. They have little weights on pendulums here, but they've all been set at the same frequency. And I'm going to try to start them as best I can, completely out of phase, randomly. So their oscillation is going to transfer energy by the swinging of this plastic sheet to the other metronomes that are out of phase to get into phase with the majority. It's inevitable that there's going to be some majority group which starts out swinging more or less together, and they are eventually going to win out. Just doing this as randomly as I can. Aha, maybe in this corner I see 4 that are pretty closely synced. Yes, now it's more like 5, 6. Now you have one that's almost completely out of phase. So every time the majority hits a beat, it's going to give a little impulse, a little push to the platform, and that push is transferred to the metronome that's not in sync. Because the platform, you can actually see this platform vibrating back and forth in sync with the majority of these metronomes. Working on this one. So we're pretty close to resonance right now.
As the metronomes achieve resonance, it's important to notice how the platform shakes.
Now, it doesn't have to just be the force that's being transmitted by the plastic platform. It could be a force at a great distance, for example, the force of gravity. Just these small, little, seemingly insignificant pushes building up over multiple cycles can have dramatic energy transfer. That is how planets do it.
Like the metronomes, the two gas giants form a resonance.
We don't know exactly how long that took, but we have some fiducial marks for timing in the solar system formation, and that means that the grand tack had to have occurred relatively quickly, talking hundreds of thousands of years, perhaps, to a million years.
The two planets retreat until they reach their current positions. The sequence of planets as we find them today is based on Jupiter and Saturn's orbits. The planets eventually achieve a sequencing that many students learn through a mnemonic, such as, "My very educated mother just served us 9 pizzas."
Was there a time when the mnemonic was scrambled? Seems very likely the answer is yes, not to mention a lot of additional letters were probably in there as well.
Jupiter's menace of the inner solar system is finally over.
If Saturn had not formed at the right time and the sufficient size, Jupiter would have continued migrating in, throwing out objects, unfortunate objects in the inner solar system, and ending up very close to the sun where it would stay. Yes, the Earth would be gone. Or the Earth would have had a terrifying encounter with Jupiter and would have had its orbit changed dramatically to gosh knows what.
There is mounting evidence that Earth had a terrifying visitor. Not Jupiter, but
Theia was this planetary body that was roughly the size of Mars. And through this collision, a lot of particles were ejected, probably completely destroyed. We don't really know how much of Theia was preserved. Probably completely destroyed. We don't really know how much of Theia was preserved.
Earth is rocked off its axis. Its surface liquefied. Chunks of Earth's mantle are shoved into space. As a planetary body, Theia ceases to exist. Its remains are absorbed by the Earth and intermingled with the debris field. A new planetary body is formed, the Moon. Further evidence is found in rock samples from the Apollo moon landings.
This is a sample from the Moon, if you can see it. This was collected by the Apollo 15 mission.
Moon rocks contain isotopes identical to those found on Earth. When the Moon arose, it is first covered with a magma ocean.
People imagine the lunar magma ocean to be like this magmatic chamber I am describing, but at the surface and covering a whole planet. I see it as this ocean, like the Pacific, but this has to be like completely magmatic, orange, and like probably like fluxing around and probably moving.
Conditions in the lunar magma are as hellish as we can imagine. But a microscopic treasure forms in the magma: crystal zircons. These are the same gemstones used in jewelry. But the zircons in the Apollo moon rocks yield a different treasure.
So those zircon are very important because we know they crystallize in this lunar magma ocean. We know roughly when they crystallize in the lunar magma ocean. So they are one of these old pieces of the moon that we are looking for, one of these old pieces that we can use to date the origin of the moon.
Zircons not only give the age of the moon, they set a specific date for the collision.
The age of the moon is 4.51 billion years old.
4.51 billion years ago, Theia becomes part of Earth and forms the moon. But the story is not over. Space probes measure the moon slipping 3.8 centimeters further away each year. One day, the moon will break free. When that day comes, there will be no more tides, no more romantic moonlit nights. Could planetary orbits be inherently unstable? Could the chaos of planetary migration return? Haute-Provence Observatory, France. It's here that a discovery from a faraway star gives one of the biggest revelations about our own solar system. The story begins when Swiss astronomers Didier Queloz and Michel Mayor noticed something unusual about a star 50 light-years away in the constellation of Pegasus. Everything about this star is ordinary. A main-sequence mid-life yellow dwarf, just like our Sun. But with one strange difference. The star at Pegasus 51 is rocking back and forth. It's a weird anomaly astronomers have never seen before. They check their instruments. Everything is working, including their new spectrograph, a device that splits the starlight from Pegasus into rainbow colors. Hidden inside the colors are patterns of lines. By tracking the day-to-day movement of these lines, astronomers make a startling discovery. Pegasus 51 has a planet. But no one has ever seen a world like this. It's half the mass of Jupiter, yet it's extremely close to its star. 9 times closer than Mercury is to the Sun. The planet at 51 Pegasus must be inside the corona, broiling in temperatures over 1,000,000 degrees Fahrenheit. Soon, another planet is found around another star, and then another, and another. Astronomers have now confirmed over 3,700 exoplanets beyond our solar system. Nearly all of them are Jupiter-class planets, grazing their host star. They're a new, previously unknown type called hot Jupiters. They're so numerous, hot Jupiters challenge theories about the origins of planetary systems.
It's very difficult to make a planet close to the star because there isn't enough mass to build a giant planet very close to the star, and there's gravitational frustrations for trying to build a planet very close to the star.
Astronomy is shaken with a new revelation. Planets do not stay put where they're born. When they're big enough, they migrate. It's a process called planetary migration. And yet, our own solar system has no hot Jupiter. Astronomers realize the Jupiter in our solar system was once on the move as well, but its migration was halted by a resonance with Saturn. Pegasus 51 shows where a planet lands when its migration is not blocked. The strongest evidence for the Grand Tack hypothesis comes not from our solar system, but from exoworlds charted around other stars.
Planetary migration is a universal concept. We see it, evidence of it, out there in extrasolar planets, other solar systems. There's no reason why planet migration shouldn't have operated in our own solar system.
The New Horizons probe finds evidence for roving planets within our solar system. While charting ancient craters on Pluto and on the surfaces of its moons, the science team discovered many craters are the same age. This suggests that they were formed by a single event. Even way out here, tiny Pluto was smashed by a wandering planet. The Pluto catastrophe may be related to other planetary migrations in the outer solar system.
It was noticed that the exact orbits of the giant planets, particularly the outer giant planets, the icy planets, Uranus and Neptune, can be explained by their migration outward. There's a point in time about 3.8 billion years ago where Uranus and Neptune trade. And it's because of what some of these mean motion resonance interactions that we were talking about earlier. So this mean motion resonance involving Jupiter and Saturn and so forth just causes all heck to break out in the solar system. Uranus and Neptune, all of a sudden at 3.8 billion years, they literally swap places, and all that debris in the outer solar system gets flung inward towards the inner solar system.
The disruption in the outer solar system causes a new wave of violence. Astronomers call this epoch the Late Heavy Bombardment. Much of the cratering we see on our moon today is from this period. It may be possible that swapping orbits with Uranus is how Neptune got its moon. Today, the epoch of planetary migration appears to be over. The solar system seems stable, but what does the future hold? Computer simulations reveal what may be the greatest threat to the solar system in over 4 billion years. It comes from a very special relationship between Jupiter and Mercury. Mercury's orbit is slowly perturbed, thanks to a subtle but constant gravitational nudge from Jupiter. A new resonance, like the one between Saturn and Jupiter that saved the inner solar system, is forming between Jupiter and Mercury. In 2001, computer models for the solar system were run 2,500 times.
They plug in the positions and the orbits of all the planets in the solar system in a computer, and they just let it run through time, through millions of years, hundreds of millions of years, billions of years, to find out whether or not these orbits are stable.
change the location of one planet, say Mercury, by 1 millimeter, and you find that that change will give completely different predictions about where everything is going to be millions of years in the future.
To see how quickly and easily things can change, we have only to go back to our metronomes.
All I have to do is stop this platform from moving so that it cannot swing freely. Now, there's no way for the metronomes to influence each other. They're good metronomes, but they're not perfect. They can't be going at exactly the same frequency in the same phase, and they're just going to fall apart because they have no way of forcing the others to go to resonance.
The same applies to planets. Any small change can disrupt their harmony or restore it.
Now that the platform is free to swing again, it can again transfer energy and sync them up just like we saw the first time.
Scientists want to understand the consequences of a destabilized planet Mercury. In one case, Mercury leaves the solar system. The loss of its gravitational pull disrupts the balance of both Venus and the Earth. Earth and Venus swap orbits. The superheated atmosphere of Venus cools. Massive rains pour onto the face of the desert planet. Oceans arise. The land cools. And the air thins. Even the remains of an ancient visitor begin to cool off. Venus becomes like Earth. But the reverse happens to the Earth. As Earth settles into Venus's orbit, temperatures rise. The air becomes unbreathable. Glaciers melt. Oceans boil. The sun looms larger in the sky, only to be obscured by a thickening cloud cover. Suffering will be great, but brief. The entire 4 billion year pageant of life is cooked in a matter of days.
Complete and utter destruction and elimination of all life on Earth. I'm not just talking about higher life. I'm not just talking about civilization, but everything. A sterilization of the planet is something that I would want to think about a bit.
Sterilized, uninhabitable, and quiet. There is another possibility, equally dark and apocalyptic. A runaway Mercury is deflected by the gravity of Venus and barrels toward the Earth. It may be a frightening encore to the opening act of our solar system. The equilibrium of the ages is over. If this scenario is correct, Mercury crashes into the Earth, just as Theia did 4 billion years ago. The question is, could it happen today? Or is it a fate far away in the future, at a time when mankind itself is but a distant memory?
The problem is that even with a perfect computer that understands all of the laws of motion perfectly, not just gravity, but all the other subtle forces that go into it, you cannot give it accurate enough initial information about the locations, the masses, the sizes, the speeds of all of the objects in the solar system.
Odds are, we may never see such a calamity. And yet, among the billions of stars in our galaxy, how many worlds are on the move? How many will share this fate?
complicated. Seriously massive objects warp the fabric of space. The heavier the star, that is, the greater its mass, the greater the distortion. So light, which would otherwise travel in a straight path, gets bent. If a star of any given mass shrinks sufficiently, its density increases until its local distortion of space is infinite. That's a black hole. A border develops separating the black hole from the space around it. Once this border has been crossed, going into the black hole, even light cannot escape. Border diameter is determined by the weight of the compressed mass. A hole with the same mass as Earth would be merely 2 centimeters across, something the mass of the Sun, 6 kilometers. That's considered the size of the black hole. Black holes are created the instant stars die. Let's say a star 20 or more times larger than our Sun reaches the end of its life and explodes. The star's own gravity then causes its remaining core to implode infinitely, becoming a purely gravitational force. When a black hole is born like this from the death of a star, its diameter is 50 kilometers at most. But one can find black holes of truly monstrous proportions, over 10 billion kilometers in diameter. Andrea Ghez is an expert on this invisible phenomenon of the black hole. It was when she saw the Apollo moon landing on TV that her interest in space was awakened.
My biggest objective in life when I was very young was to become a ballerina. So I think I see things spinning in space now as opposed to myself. But yeah, your path the path was unclear. And today I view doing astronomy and studying the black hole as putting together one big puzzle.
Donald Lyndon Bell predicted that a supermassive black hole lurks at the heart of every galaxy. Andrea Ghez tried to find such a black hole in our own Milky Way galaxy.
Or actually, the first thing that we're trying to do is watch how stars move. That's the key to finding that there's a black hole. And the way you do this is by pointing your telescope at the center of the galaxy and using a technique that allows you to see the stars around the black hole. So here's the black hole. And what you want to do is we want to be able to see a star. You want to be able to see a star make a complete orbit around the center.
Ghez followed the movements of the stars for years, plotting their trajectories. If they were in fact orbiting some unseen object, then that would be proof of a black hole. The center of the Milky Way, however, is 26,000 light years from Earth. Ascertaining the movements of stars around a point so far off in space is no easy matter. Mauna Kea, Hawaii, home to several giant telescopes. Ghez used one of the observatories on this summit, the Keck Observatory. The Keck has 2 of the largest telescopes in the world, with primary mirrors that are 10 meters in diameter. Gez's observations here began in 1995. Her special equipment succeeds in doing just that. The new method is called adaptive optics. It brings the stars into focus. Corrected for atmospheric fluctuations, the stars shine much more clearly. Gez, who did not yet have adaptive optics, was at a disadvantage. She minimized atmospheric fluctuations by restricting exposure time in imaging the stars. Meticulously, she charted their movements. Success or failure depended on choosing the right stars to follow. At first, both teams were following a star designated SO1. But Gez's attention was drawn to another star.
Another star which people were very excited about in the earliest days was SO1. It was the star that was moving fastest initially. But it was SO2 that, as it got closer to the black hole, has become the fastest moving star that we've known about.
This graphic represents Gez's findings. Knowing that stars orbit the center of the galaxy was not enough to prove the existence of a black hole. In January of 2002, another star, designated SO2, was observed to be behaving strangely. It was executing a blindingly fast and tight orbit, clocked at 5,000 kilometers per second, as if being swung violently around and around.
These were incredibly exciting times because, of course, at every stage of this experiment, people said, you can't do it, or what you're seeing isn't what you should be seeing. So we initially saw that they were moving fast, and people said, well, these stars aren't bound to the galaxy. You're not going to see them curve.
Yet SO2 was indeed curving in a rapid orbit. This is an actual imaging sequence. Exhaustive analysis showed it to be a giant star with a mass equivalent to 10 suns.
The only thing that can make stars move that fast is a lot of mass. These stars are moving because there's a lot of gravity. And the only thing that makes that much gravity in that small a space is a supermassive black hole.
With their adaptive optics, the strange behavior of SO2 had not escaped the notice of the European team either. They succeeded in imaging SO2 at around the same time.
Of course, that was the moment everybody was extremely excited about, that we saw, wow, that orbit is proving there must be a mass, and we can measure the mass, we can actually calculate the mass. It's an easy calculation, any student can do it, and the result is extremely fascinating. This mass, which we are seeing in these images, is 4 million times the mass of the Sun.
Finally, after 10 years of observations, it was determined that a supermassive black hole does in fact exist in the center of our galaxy. And it is bigger than was imagined, by many orders of magnitude. Black holes created when stars die are typically 50 kilometers in diameter at most. But the one at the center of our galaxy is gigantic. The diameter is estimated to be 24 million kilometers. That's like 17 of our suns lined up in a row. Round this monster black hole rushes SO2, a giant blue star, at 5,000 kilometers per second, about 200 times the speed at which the Earth orbits the Sun. That is a speed made possible only by the immense gravitational pull of a black hole. In the center of our own galaxy, but far from Earth, unfolds a dance of the stars. It was this dancing of the stars that proved the existence of a supermassive black hole.
It was an idea, but, you know, far out and not very much considered as natural, and it remained that way for about 15 years.
Lyndon Bell had predicted that a supermassive black hole exists at the center of every galaxy. Apart from observing the orbits of the stars, there's another way to prove the existence of such a black hole. That's to observe the moment when a black hole swallows up stars or gases. As gases are sucked into a black hole, they first flatten into a disk. Friction causes them to superheat and to emit intense radio waves. If these radio waves can be detected, that can indicate the presence of a black hole. The largest telescope in the world for detecting extremely high-frequency millimeter-band radio waves is the 45-meter radio telescope at the National Astronomical Observatory of Japan. It was in fact a Japanese scientist who first proved Lyndon Bell's theory that a supermassive black hole lies hidden in every galaxy. It happened in 1990, 21 years after Lyndon Bell's prediction. Naomasa Nakai was working at the Nobeyama Radio Observatory, studying gases at the centers of galaxies. He was interested in a galaxy adjacent to the Big Dipper. Galaxy M106, a spiral galaxy 21 million light-years from Earth. Radio waves had been reported to be issuing regularly from the nucleus of M106.
銀河の中でそういう規則正しく電波、光もそうですけど、変わるというのはそういう現象はほとんどないんです。だから非常に驚いてですね、本当にそういう、電波の強さが規則正しく変わっているのかどうかというのを調べようとしたんです。
In addition to a 45-meter diameter parabolic dish antenna, the Nobeyama Radio Observatory has some world-class instrumentation. 8 spectrometers capable of minute observation of radio waves. A single spectrometer is sufficient to observe radio waves from the nucleus of a galaxy. But to be thorough, Nakai used 2 spectrometers for the very center of the galaxy and flanked them with the 6 remaining ones. That decision to use all 8 instruments led to the discovery of the century. Nakai had simply wanted to put all his spectrometers to some use, but the results astonished him. There were surprising spikes on both ends of the combined graphs. Nakai was especially struck by the ones on the left. This indicated something moving at high velocities never before observed.
今まで銀河でですね、そういう大きな速度に見つかったことは全くないわけです。これに気がついた時にはもう体中がですね、熱くなりましてですね、これはとんでもないことだというふうに思いましたけど。
More detailed observations were made using a high-resolution telescope. They found something remarkable at the core of the galaxy. A spinning disk. This was a structure very like the disk formed by gases being sucked into a black hole. The spikes recorded by the 8 Nobayama spectrometers were from this disk. The disk was spinning furiously, 3.6 million kilometers an hour. Detailed analysis revealed that the mass at its center was equivalent to 39 million of our suns. It was indeed a monster black hole.
45メーターなければそういうブラックホールは見つかってなかったです。それから電波分光計が8台なければですね、とても見つかってなかったですね。
When his discovery was published in 1995, Nakai received a letter. The letter read, "I have been waiting 26 years for such proof, and congratulate you on your great discovery." The letter came from England. The sender? None other than Donald Lyndon Bell, who had predicted the existence of supermassive black holes.
I was very happy because I didn't feel that I absolutely knew. I thought it was likely, and gradually I thought it was more and more likely.
A black hole equivalent to 39 million solar masses was sucking in huge volumes of gas with its tremendous gravitational force. The dark object in the center of this artist's conception is a black hole. Its diameter is awesome, as if 160 of our suns were lined up in a row. It is now thought that almost all galaxies have these supermassive black holes at their center. The most advanced observational instruments are detecting ever larger black holes. Situated outside Earth's atmosphere, the Hubble Space Telescope can see space objects with great clarity. Hubble took aim at NGC 7052, a galaxy located 37 million light-years away. The image it captured was that of a huge disk, comprised of gases and stars. In its center, there ought to be a supermassive black hole.
When we got this image, I was just super excited, because it was such beautiful, rich detail that I really knew right when I saw this that we were going to be able to get, excellent spectra and really be able to determine whether this galaxy has a black hole and how massive it is. So I was very, very excited.
The galaxy was indeed harboring a supermassive black hole. A black hole equivalent to 300 million solar masses. That's more than 70 times larger than the one at the center of our own Milky Way galaxy. A black hole with the diameter of 1,200 of our suns lined up in a row. And Hubble has spotted an even larger one, an ultramassive black hole. This one is in M87, 59 million light-years away. Scientists had long been puzzled by a band of white light there. When Hubble was trained on the galaxy's core, the band of white light was revealed to be a gigantic jet of gases. As the gases are sucked violently into the black hole, a portion of them are ejected in the form of this jet. The mass of the black hole at the base of this jet has been calculated to be 6.4 billion solar masses. That's 10 million times greater than the supermassive black hole at the center of our Milky Way galaxy. In size, its diameter is equal to 25,000 of our suns lined up in a row. Then, in 2011, the largest black hole in history was discovered. In the galactic nucleus of NGC 4889, there's an unimaginably monstrous black hole, with a mass equivalent to 9.7 billion times that of our sun. What scientists are most eager to elucidate now is the process by which these black holes become so large. They may start with the death of a star, but how do they then grow to billions of times their original size? Trinity College at the University of Cambridge. The Reese diagram, as it was called, charted the possible routes.
If you're going to be at that, you need to have...
In the 30 years since the Reese diagram was published, there has been a succession of discoveries of supermassive black holes. At the same time, the study of their birth has also been progressing. One scenario suggested by Reese was the consolidation of several smaller black holes. At the end of their lives, stars explode, forming relatively small black holes. Hundreds of millions of them may cluster together, merging into one supermassive black hole. This is NASA's space-based Chandra X-ray Observatory. Chandra has been examining a region where black hole consolidation is thought to be taking place. Galaxy NGC 6240 is located 400 million light-years from Earth. Actually, two galaxies are colliding there. As Chandra examines their galactic cores, two bluish-white spots appear. They are both massive black holes, one at the center of each galaxy.
This blue region here is a blow-up of the center, and you can see there are two little sources there, one brighter and one a bit fainter. But each of those, when we look at the spectrum, shows a very characteristic sign that this is just emission from a supermassive black hole in each case, which has never been seen before until we had the beautiful Chandra image and could separate the two.
Two black holes in close proximity to each other, but they cannot soon merge. Rather like the Earth and the Moon in their perpetual dance, the two black holes orbit about each other without colliding. So what about Reese's concept of black holes merging to form a supermassive black hole? Masayuki Umemura uses a supercomputer to create simulations of black hole mergers. Here, he simulates the behaviors of 10 black holes of equivalent mass. The first consolidation happens far sooner than expected. It takes only 50 million years. The process repeats. Within about 500 million years, 5 black holes have merged into one.
もともと銀河が持っていたブラックホールが、大きな銀河に取り込まれたときにブラックホールごと、中に取り込まれるわけですね。そうすると2つではなくて、例えば大きな銀河の中に10個のブラックホールがあるというような状況が最初に起こった可能性が高いということをまず想定しました。
Let's look at our actual universe. There are galactic collisions and mergers all over the place. And when galaxies merge, the thinking is that their black holes merge too. Wherever galaxies cluster, there's bound to be a cluster of black holes. That means a process of consolidation of black holes. This conforms to actual observations of our universe. A second Reese diagram scenario has a seed black hole becoming supermassive by swallowing up gases and stars. In that scenario, the monster is born by gulping down an unbelievable quantity of gases, equivalent to hundreds of millions of our sun. The gases are sucked in with so much force that the friction produces incredible heat. That violent process emits intense light and X radiation and blows away surrounding gases. The result is that there are no more gases to feed on, and the black hole ceases to grow. But how is it that such a huge quantity of gases could be sucked in the first place? Gases that are being sucked in, blowing away other gases. Ken Osuga studies this contradiction. He has found a particular mechanism within black holes by which they can continue to draw in vast amounts of gases. He's prepared a simulation of one scenario for how supermassive black holes may be created. As a black hole sucks in gases, it generates magnetic field lines, which penetrate the surrounding gas disk like hoops. Thus embedded, they are then distorted by the swirl of the disk. As the disk swirls, the magnetic field lines are caught in a spiral vortex, twisted and coiled like a spring. This is a plasma jet. A portion of the disk's gases, charged with energy such as light, shoots out in opposite directions perpendicular to the disk. Any remaining gases are sucked into the black hole, which grows supermassive.
私たちの研究の結果はですね、光の力が非常に強くなったとしても、ジェットは噴出するけども、ガス円盤からガスは変わらず吸い込まれ続けるということを明らかにしました。これによってですね、ブラックホールは大量のガスを吸い込むことができますので、巨大ブラックホールに成長するのに一役買うということを証明することができました。
Hubble has captured this actual image of an intense jet erupting from the center of a galaxy. The gas-guzzling scenario for supermassive black hole creation. As outlined in the Reese diagram, thus seems persuasive. Martin Rees developed several theories of supermassive black hole formation. One was by the continuing consumption of gases. Another was by the consolidation of smaller black holes. But the Rees diagram indicated a third possibility as well. Under this third scenario, just after the creation of the universe, large clouds of gas condensed into supermassive black holes directly, without first becoming stars at all. Recently, evidence for this third scenario has also come to light. By combining information from the Chandra X-ray and Hubble Space Telescopes, Priya Natarajan hunts for supermassive black holes created at the inception of the universe. These far-off galaxies were photographed by Hubble. Among those circled on the screen are some that are 12 billion light-years away. They are small galaxies, born immediately after the universe itself. Some 200 of them have been identified. Here's one as perceived by Chandra. And it already has a supermassive black hole in it. Natarajan was surprised to discover that almost all 200 of them had supermassive black holes in them. If so many supermassive black holes were already present immediately after the creation of the universe, then that lends powerful support to the third scenario in the Rees diagram.
So just as we think that a gas cloud that is collapsing could make the first star reasonably easily, the conditions that you need for making a black hole seed directly without forming a star, instead of forming a star, also exist in the early universe.
Efforts are also underway to confirm the third Rees diagram scenario computationally.
I think it is the first time that there is a model showing that it is possible to produce a precursor of a big black hole in the form of this supermassive black hole.
This is a giant gas cloud, 100 light-years in diameter. 70,000 years after it formed into a gas cloud, its gases were compressed into a disk 1 light-year across. The gas disk was equivalent in mass to 100,000 of our suns. It then condensed further, compressed by its own weight, giving rise to a supermassive black hole. So the third scenario in the Rees diagram, going directly from gas cloud to black hole, is a real possibility. Studies of the origins of these supermassive black holes are ongoing. The latest research reveals that the supermassive black holes do not simply grow fat, consuming everything nearby. Surprisingly, they exert a huge constructive effect on the space around them. What these remarkable monsters call home is a galaxy's core. More specifically, it's inside the concentration of stars called the bulge. The shape and size of the bulge varies with each galaxy. John Cormandy has investigated the relationship between the mass of a bulge and of its supermassive black hole. The first galaxy he observed was Andromeda. The supermassive black hole here is equivalent to 150 million solar masses. The bulge is approximately 1,000 times greater in mass. Next, he looked at the Sombrero galaxy. The black hole here is 1 billion solar masses. The mass of the bulge is approximately 1,000 times that. Plotted on a graph coordinating the masses of the bulges with those of the black holes, the galaxies form a nearly straight line. In most galaxies, the black hole to bulge ratio of masses is 1 to 1,000. This strong relationship between the mass of supermassive black holes and their galaxies' bulges surprised many scientists.
We know that when gas densities get very big, you get a burst of new stars being formed. And so at the same time when this burst of stars is making the bulge, the rest of the gas is being fed to the black hole and making the black hole bigger. So you get lots of new stars and you get higher mass black hole, and the two correlate.
A galaxy comprises hundreds of billions of stars. It turns out that at the galactic cores, the black holes and the bulges have a deep interrelationship. A giant bulge will correlate with a giant black hole. A small bulge with a small black hole. This strange law of outer space may mean that galaxies and black holes evolve together. Andrea Ghez discovered the supermassive black hole at the center of our own Milky Way galaxy. She also found evidence that it performs an astonishing function within the galaxy's bulge.
We've had one surprise after another in our study of the center of the galaxy. What we see is that they're very massive stars, which tells us that they're very young stars. And the last thing you expect near a black hole is to find a very young star, because black holes are very inhospitable to star formation. They should just tear apart any cloud that might eventually become a star. So you really don't expect to see young stars, baby stars near a black hole. And yet all the stars that told us that there's a black hole are the ones we predicted shouldn't be there. So it's one mystery after another.
Near the supermassive black hole at the center of the Milky Way, Ghez found many baby stars. This suggests something astounding, that new stars may be emerging from the gases that originally accumulate around a black hole. The effect black holes have on surrounding space is not limited to the birthing of stars. A project spearheaded by NASA called Tanami is endeavoring to capture distant galaxies. Tanami involves the participation of radio telescopes in a dozen locations in the southern hemisphere, chiefly in Australia, but also in Chile, South Africa, and the South Pole. One of its targets is a galaxy located 14 million light-years from Earth, Centaurus A. This is the image they obtained. a clear view of a plasma jet violently shooting out from an invisible black hole. The jet bursts out at 30% of the speed of light. Analysis of this jet turned up something quite unexpected. The jet shooting out of the black hole even escapes the galaxy itself. Its plume expands for a distance of 1,000,000 light years. So the black hole doesn't just guzzle down gases, it sends out the stuff that stars are made of far beyond its own galaxy. The role of the supermassive black holes in the universe is still largely mysterious, but scientists are learning more and more.
Cosmos looks the same from Britain and from Japan. Indeed, the night sky is the same to all of us and has been the same to all our ancestors throughout human history. It's the one common feature of all humanity. They've all looked up at the night sky and wondered at it and interpreted it in their own way. It's a wonderful story where we found all these extraordinary objects in the universe, and we can understand these vast cosmic horizons in a way that our ancestors could only have dreamed of. So it's a wonderful story.
Supermassive black holes, monsters in the galactic cores. They may gobble up everything around them, but they also give birth to stars and send out energy-rich materials into the universe. Some came into being at the same time as their galaxies and grew along with them. He was interested in a galaxy adjacent to the Big Dipper. Galaxy M106, a spiral galaxy 21 million light-years from Earth. Radio waves had been reported to be issuing regularly from the nucleus of M106.
銀河の中でそういう規則正しく電波、光もそうですけど、変わるというのはそういう現象はほとんどないんです。だから非常に驚いてですね、本当にそういう、電波の強さが規則正しく変わっているのかどうかというのを調べようとしたんです。
In addition to a 45-meter diameter parabolic dish antenna, the Nobeyama Radio Observatory has some world-class instrumentation. 8 spectrometers capable of minute observation of radio waves. A single spectrometer is sufficient to observe radio waves from the nucleus of a galaxy. But to be thorough, Nakai used 2 spectrometers for the very center of the galaxy and flanked them with the 6 remaining ones. That decision to use all 8 instruments led to the discovery of the century. Nakai had simply wanted to put all his spectrometers to some use, but the results astonished him. There were surprising spikes on both ends of the combined graphs. Nakai was especially struck by the ones on the left. This indicated something moving at high velocities never before observed.
今まで銀河でですね、そういう大きな速度に見つかったことは全くないわけです。これに気がついた時にはもう体中はですね、熱くなりましてですね、これはとんでもないことだというふうに思いましたけど。
More detailed observations were made using a high-resolution telescope. They found something remarkable at the core of the galaxy. A spinning disk. This was a structure very like the disk formed by gases being sucked into a black hole. The spikes recorded by the 8 Nobeyama spectrometers were from this disk. The disk was spinning furiously, 3.6 million kilometers an hour. Detailed analysis revealed that the mass at its center was equivalent to 39 million of our suns. It was indeed a monster black hole.
$45メーターなければそういうブラックホールは見つかってなかったです。それから電波分光計が8台なければですね、とても見つかってなかったですね。
When his discovery was published in 1995, Nakai received a letter. The letter read, "I have been waiting 26 years for such proof, and
4 million times the mass of the Sun.
Finally, after 10 years of observations, it was determined that a supermassive black hole does in fact exist in the center of our galaxy. And it is bigger than was imagined, by many orders of magnitude. Black holes created when stars die are typically 50 kilometers in diameter at most, but the one at the center of our galaxy is gigantic. The diameter is estimated to be 24 million kilometers. That's like 17 of our suns lined up in a row. Round this monster black hole rushes SO2, a giant blue star, at 5,000 kilometers per second, about 200 times the speed at which the Earth orbits the Sun. That is a speed made possible only by the immense gravitational pull of a black hole. In the center of our own galaxy, but far from Earth, unfolds a dance of the stars. It was this dancing of the stars that proved the existence of a supermassive black hole.
It was an idea, but, you know, far out and not very much considered as natural, and it remained that way for about 15 years.
Lyndon Bell had predicted that a supermassive black hole exists at the center of every galaxy. Apart from observing the orbits of the stars, there's another way to prove the existence of such a black hole. That's to observe the moment when a black hole swallows up stars or gases. As gases are sucked into a black hole, they first flatten into a disk. Friction causes them to superheat and to emit intense radio waves. If these radio waves can be detected, that can indicate the presence of a black hole. The largest telescope in the world for detecting extremely high-frequency millimeter-band radio waves is the 45-meter radio telescope at the National Astronomical Observatory of Japan. It was in fact a Japanese scientist who first proved Lyndon Bell's theory that a supermassive black hole lies hidden in every galaxy. It happened in 1990, 21 years after Lyndon Bell's prediction. Naomasa Nakai was working at the Nobeyama Radio Observatory, studying gases at the centers of galaxies. Shine much more clearly. Gez, who did not yet have adaptive optics, was at a disadvantage. She she minimized atmospheric fluctuations by restricting exposure time in imaging the stars. Meticulously, she charted their movements. Success or failure depended on choosing the right stars to follow. At first, both teams were following a star designated SO1. But Gez's attention was drawn to another star.
Another star which people were very excited about in the earliest days was SO1. It was the star that was moving fastest initially. But it was SO2 that, as it got closer to the black hole, has become the fastest moving star that we've known about.
This graphic represents Gez's findings. Knowing that stars orbit the center of the galaxy was not enough to prove the existence of a black hole. In January of 2002, another star, designated SO2, was observed to be behaving strangely. It was executing a blindingly fast and tight orbit, clocked at 5,000 kilometers per second, as if being swung violently around and around.
These were incredibly exciting times because, of course, at every stage of this experiment, people said, you can't do it, or what you're seeing isn't what you should be seeing. So we initially saw that they were moving fast, and people said, well, these stars aren't bound to the galaxy. You're not going to see them curve.
Yet SO2 was indeed curving in a rapid orbit. This is an actual imaging sequence. Exhaustive analysis showed it to be a giant star with a mass equivalent to 10 suns.
The only thing that can make stars move that fast is a lot of mass. These stars are moving because there's a lot of gravity. And the only thing that makes that much gravity in that small a space is a supermassive black hole.
With their adaptive optics, the strange behavior of SO2 had not escaped the notice of the European team either. They succeeded in imaging SO2 at around the same time.
Of course, that was the moment everybody was extremely excited about, that we saw, wow, that orbit is proving there must be a mass, and we can measure the mass, we can actually calculate the mass. It's an easy calculation, any student can do it, and the result is extremely fascinating. This mass, which we are seeing in these images, is...
You do this is by pointing your telescope at the center of the galaxy and using a technique that allows you to see the stars around the black hole. So here's the black hole. And what you want to do is, we want to be able to see a star. You want to be able to see a star make a complete orbit around the center.
Gez followed the movements of the stars for years, plotting their trajectories. If they were in fact orbiting some unseen object, then that would be proof of a black hole. The center of the Milky Way, however, is 26,000 light-years from Earth. Ascertaining the movements of stars around a point so far off in space is no easy matter. Mauna Kea, Hawaii, home to several giant telescopes. Gez used one of the observatories on this summit, the Keck Observatory. The Keck has two of the largest telescopes in the world, with primary mirrors that are 10 meters in diameter. Gez's observations here began in 1995. But Gez and her team were not the only ones searching for a supermassive black hole in the center of our galaxy. A European team based in the heart of Germany had also been hunting the same monster. The leader of these star trackers is Stefan Galessen.
They have a 10-meter telescope. We have an 8-meter telescope. So our telescope is a bit smaller. However, we are on the southern hemisphere, where the galactic center is visible for more hours. So we can observe from February to October.
The European team conducts its observations at the Paranal Observatory in Chile. The VLT array there comprises 4 8.2-meter telescopes. But even with such advanced technology, success is elusive. The problem is Earth's atmosphere. Atmospheric fluctuations blur the stars. April 2002, the European team installs epoch-making new equipment. From the VLT at Paranal, they shoot laser beams into the night sky to measure and adjust for those atmospheric fluctuations. Their special equipment succeeds in doing just that. The new method is called adaptive optics. It brings the stars into focus. Corrected for atmospheric fluctuations, the stars shine. The black hole is a bizarre space object, defined by the absence of everything except gravitational force. How do scientists wrap their minds around it? It's complicated. Seriously massive objects warp the fabric of space. The heavier the star, that is, the greater its mass, the greater the distortion. So light, which would otherwise travel in a straight path, gets bent. If a star of any given mass shrinks sufficiently, its density increases until its local distortion of space is infinite. That's a black hole. A border develops separating the black hole from the space around it. Once this border has been crossed, going into the black hole, even light cannot escape. Border diameter is determined by the weight of the compressed mass. A hole with the same mass as Earth would be merely 2 centimeters across, something the mass of the Sun, 6 kilometers. That's considered the size of the black hole. Black holes are created the instant stars die. Let's say a star 20 or more times larger than our Sun reaches the end of its life and explodes. The star's own gravity then causes its remaining core to implode infinitely, becoming a purely gravitational force. When a black hole is born,
2017 was a busy year for scientists of all sorts, the professional and the enthusiast alike. From a predictable astronomical rarity to surprise discoveries deep underground. It was a year that saw long-held beliefs challenged by newly found wonders. Breakthroughs that led to innovations. and a glimpse 130 million years into the past. In August 2017, alarms sounded at the most sensitive scientific devices ever constructed. In Washington State, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected faint disturbances from deep space. The signal also hit LIGO's sister facility in Louisiana. Gravitational waves had reached Earth.
Gravitational waves are ripples in space-time. Space-time is incredibly dense. So to cause ripples, you have to have some sort of object that has enormous gravity, like a black hole or a neutron star. And when these objects are rapidly accelerating, they bend space-time and create these ripples that then travel through the universe to our detectors on Earth, like the one last August.
On high alert, the LIGO team quickly reached out to Virgo, its European counterpart in Italy, who confirmed that they too had detected gravitational waves. And then, as if by destiny, the stars would align once more to pave the way to a groundbreaking discovery.
Just 2 seconds later, with the Fermi Gamma Ray Space Telescope, we detected a short, bright flash of high-energy light that we call a gamma ray burst. This alerted the entire astronomical community to the fact that something very exciting was happening.
Using data collected from LIGO, Virgo, and Fermi, 70 ground and space-based telescopes scoured the edge of galaxy NGC 4993, some 130 million light-years away from Earth, searching for a small flash of light amidst a sea of stars. It would take less than 12 hours after the alarms rang at LIGO for Earth to have visual confirmation of a never-before-seen astronomical event.
What we saw was the result of the merging of two neutron stars. When they merged, they created an explosion in space-time. Those ripples went out across the universe as gravitational waves and were detected on Earth. The matter involved gave off gamma rays and other forms of light.
Neutron stars are the collapsed cores of massive stars left behind after a supernova explosion. No larger than a mid-sized city, these dense stars have 10 to 60% more mass than our Sun. This pair of stars, 200 miles apart, were locked in each other's orbit for over 11 billion years. But as they started accelerating and moving inwards, their orbit quickened from 30 times a second to an astonishing and unsustainable 2,000 orbits a second. Then, 130 million years ago, they collided in a resounding explosion. Peering into the past, telescopes were able to see the remnants of one of the universe's most impressive fireworks shows. A bright flash of blue followed the initial explosion, growing redder and duller as the days passed, until eventually fading to black.
The conditions around these merging neutron stars have densities and temperatures completely unlike anything we can do on Earth.
The violent explosion was observed to have produced 200 Earth masses worth of gold and 500 Earth masses of platinum, revealing for the first time the origins of heavy metals in our galaxy.
We think that all the gold in the universe was formed in explosions of this kind. After the explosion happens, the gold is spread out into the gas and dust of the interstellar medium. Later on, that gas and dust collapses into brand new stars and brand new planetary systems.
And these weren't the first gravitational waves detected by LIGO this year. 2 separate events have been measured before, including a pair of monstrous black holes that collided to form a single spinning hole 53 times more massive than the Sun.
We received a perfect signal from this last merger. It traveled 3 billion light-years to get here. In any given galaxy, one of these events might only happen once every million years, but we're now able to monitor about 10 million galaxies at a time. It's a new type of astronomy.
But while we wait for gravitational waves that can open a window on the origins of our universe, volcanic activity off the coast of Japan is presenting scientists with a picture of Earth's early history, when land first rose from the seas. Violent eruptions spew a steady stream of lava and rocks, expanding the newly emerged island of Nishinoshima 3 square kilometers in just 5 short months this year. These most recent blasts stopped in August, but could resume at any time. Situated atop the junction of 4 tectonic plates, the Japanese islands offer stunning insights about the formation of a variety of landscapes. Analysis of Nishinoshima's magma shows it to be andesitic, similar to the composition of continental crust. Monitoring the growth of Nishinoshima, geologists hope to learn more about the forces that led to the birth of the world's 8 continents. Yes, not 7, 8. In February 2017, the Geological Society of America published a startling paper. Zealandia, Earth's hidden continent. Geologist Nick Mortimer was the lead author.
To discover Zealandia is to change the map of the world, quite literally. Beforehand, most people would say, yes, we've got 7 continents, they could count them off. But now, the world map's changed and we've got an 8th one on there.
In the beginning, there was no search for Zealandia. Mortimer and his team discovered the shallow submerged continent while performing geological work aboard a research vessel off of New Zealand's coast.
And so what the various geological investigations have led us to is that we do have the components of a continent here. When you pull the plug on the world's oceans, you literally reveal the continent of Zealandia.
Mortimer and his team confirmed 4 geological markers, the qualifying criteria for a continent: height, a varied geology or diversity of rock types, a thick crust, and ultimately size. Is it big enough? Corroborating data include rock samples, ocean drill cores, and satellite microgravity measurements, translated into bathymetric or elevation maps of the sea floor. Situated between the Pacific Plate and the Australian Plate, tectonic forces squeezed Zealandia, raising out of the water what we know today as New Zealand. With 94% of Zealandia underwater, the islands of New Zealand and New Caledonia are just the tip of this continental iceberg. And measuring in at 4.9 million square kilometers, Zealandia is 6 times bigger than the so-called microcontinent of Madagascar, and more than twice as large as Greenland, which also happens to be attached to North America. To understand Zealandia's origins, we must travel back in time to the time of the supercontinent Gondwana, comprised of what we know today as Africa, South America, Antarctica, and Australia. When Gondwana split apart 80 million years ago, it was a bit like the stretching of bread dough in a kitchen.
And then you start to pull that big lump of dough apart. And if you pull slowly, some of those pieces will stretch and get thinner.
Just like Zealandia, which broke off and slowly sank because of its relatively thin continental crust.
It's not as thick as the main continents, but it is thicker than the ocean crust. And geophysicists know that when you have thin crust, it floats lower in the mantle, and so it sits lower elevation-wise, and that explains, in very simple terms, why Zealandia is so submerged. Now that we've got Zealandia in the scientific arena, we do hope to consolidate it and to promote Zealandia in New Zealand schools first of all, and we hope to get it in atlases, on globes. We hope that Zealandia will become as common and well known as any of the other major continents.
Of course, the initial buzz about Zealandia can only help its name recognition.
The notion that something so big and so important could be hidden for so long, I think captured people's imagination.
Out of sight, out of mind, no more. Of course, not everything that's undetected is so obviously obscured. And one remarkable discovery this year offers clues about how some prehistoric creatures could hide in plain sight. In northern Alberta, Canada, the remnants of a 110-million-year-old dinosaur from the late Mesozoic era is providing the world with an unprecedented look at a new species, the nodosaur. A fossil so pristine and complete that it shows the texture, patterns, and color of a prehistoric giant.
The nodosaur is the best specimen we have, and it's the closest you'll come, until we find a better one, in terms of coming face to face with a dinosaur.
The nodosaur is next to surreal. A petrified beast caught by Medusa's gaze.
We knew it was good, but we didn't know how good it was. I think it's the best preserved armored dinosaur in the world. I'm calling this the Rosetta Stone for armored dinosaurs.
The anatomy of the new species has already given scientists clues to how these animals evolved, how they radiated and diversified through time. And it doesn't stop there.
The skin is preserved. It's not just the impression of the skin. We actually have some of the original biomolecules preserved. One of the cool things that they tell us for this specimen is that the animal had at least a component of reddish-brown pigment to its skin. The coloration aspect is very exciting. So it's cool to know what color it was, but it's actually more exciting when that has some implications for how the animal lived.
Researchers believe the nodosaur was darker on the back and lighter on its sides and underside, a method of camouflage called countershading.
Now keep in mind, this was a 5.5 meter long, 10.5 animal covered in armor, but it still has camouflage. And to us, that just illustrates how intense the predation was back in the Cretaceous. You had these very large, meat-eating dinosaurs, and they would have also been very visual predators. So it actually kind of just shows you how extreme that ecosystem likely was back in the Cretaceous.
The plant-eating, slow-moving beast only stood a chance because of its impenetrable coat of armor.
We see 3 rows of osteoderms. Those are what are called cervical rings, and it's armor that would have protected the neck of the animal. And as we move to the side, we see this giant parascapular spine. It's basically a big armor spine coming off the shoulder, and it's about 0.5 meter long.
And the spectacular specimen still has many secrets to unveil. The next focus of study are the contents of the nodosaur's stomach.
In addition to having skin preserved all over most of the surface of the animal, we also have abundant gut contents. So the last meal of the animal preserved inside. And this is what that stuff looks like. So we're currently doing all sorts of work on this, geochemical work, histological work, and CT scanning, trying to figure out what these spheroid structures are. And there's been many ideas that part of the diversification of dinosaurs is tied to the diversification of flowering plants. And it would be great to see exactly which types of plants this guy was eating, and if that hypothesis makes sense.
We know what dinosaurs ate, how they fought, and now what they looked like. But there are still many questions to be answered. And Alberta might just be the place to find them. It's estimated that there are thousands of fossils hidden underneath the earth. But when a 6-mile-wide asteroid struck the Yucatan Peninsula 65 million years ago, dinosaurs had nowhere to hide. And the resulting global cataclysm of earthquakes, firestorms, and tsunamis ultimately led to their extinction. Some animals, however, managed to survive. But how? Since its discovery in 1978, investigations of the asteroid's impact crater include data from seismic images and recently collected core samples from deep within the site at Chicxulub. The data paints a devastating picture of destruction and led scientists to create a broad new survival theory, focusing on habitat and diet adaptability. When dinosaurs perished and a vast new ecospace emerged, the surviving species expanded rapidly to fill it. This is called adaptive radiation. A recent study shows that 1 out of 10 frog species descend from the original 3 frog species that survived the Cretaceous-Tertiary extinction event. Frogs were able to escape extinction for a number of reasons. They live in an aquatic habitat that offered protection. Their small size and unique metabolism allow for better endurance of environmental stress. Eventually, when vegetation returned, they were able to diversify worldwide and adapt to new lives in trees. Birds, too, exhibited the same adaptive radiation around the same time. A newly found 62-million-year-old mousebird fossil in New Mexico helped paleontologists map the diversification of land birds, which can be traced back to 9 original ancestors which survived the event. Warm-blooded, birds' feathers insulated them from temperature extremes. Their small size and ability to fly allowed for easier escape from hostile and barren terrain. And their diet of seeds, worms, and insects gave them the edge after much of the Earth's surface plant life had died. In the end, the ability to adapt to changing conditions proved a key characteristic for the survival of many ancient animals, including our smallest mammal ancestors. Just as it may be for humans today, as we confront the challenges of climate change. The city of Miami Beach already knows what it means to wade through sea level rise. In recent years, residents have experienced elevated high tides at certain times of the year. Known as king tides, these events are clear evidence of incremental increases.
Right now, we are definitely witnessing sea level rise impacts, these high tide flooding events that are growing in severity, more often, deeper, more widespread. That's sort of a pattern that we expect will continue.
That means huge financial costs by the year 2100. Another predicts 2.5 million Miamians could become sea level refugees and leave the area. It's not only Miami. All around the world, sea levels are expected to rise. The question is, by how much? In adopting a multi-pronged approach, Miami Beach has committed $400 to $500 million to combat sea level rise, building water pumps and raising their defenses.
With the continued issue of climate change and sea level rise, we're seeing an increase of water level every year. We had to make changes to adapt to this future condition. What you're seeing here, we put a boardwalk initially to give some height, but we found that that wasn't protecting the city. What we've done here is we've increased the levels of our new seawall. The new wall you see in the background here is our new standards. This is good for approximately another 50 years, and we're going to see water levels challenging even that new seawall.
Raising its elevation, Miami Beach seeks to stay dry and take control of its future.
The city's philosophy, our culture, is rising above. We believe we can meet the challenge. And the challenge is not only in rising above, meaning elevation, it's rising to and withstanding the challenges that come with sea level rise due to climate change. As a city engineer, I have complete faith that we can win. We can mitigate. We can survive.
Of course, the Earth's oceans have risen and fallen many times during the planet's history. And new archaeological evidence suggests these shifting shorelines may conceal clues about the earliest Americans. Until just recently, archaeologists generally agreed that the earliest people to populate North America were the Clovis people, dating back to some 12 to 13,000 years ago. But a group of scientists in San Diego, California, have a different theory.
We have the bones, the fossils, the distribution, the rocks, the date. We have evidence for humans in North America 130,000 years ago. We realize that that is a startling claim.
But the scientific community is struggling with the idea that humans arrived in North America 130,000 years ago.
The study of early humans in the New World has been very political and very controversial for over 125 years.
It's an old mystery yet to be solved, deciding who got to North America first and when.
Welcome, and thank you for joining us this morning at the San Diego Natural History Museum as we share some exciting news about a discovery made right here in San Diego.
Well, back in 1992, Caltrans was doing improvements to State Route 54, which involved adding a couple new travel lanes. And Richard Cerruti, who's a field paleontologist here at the museum, was monitoring the excavations on the very north side of the freeway alignment and saw this little puff of let's say, tusk material being scraped up by an excavator and said, "Stop, let me go look at this."
The bones that Richard Cerruti found belong to an ancient mastodon.
That's one tooth, and it's characteristic of American mastodon.
Were these giants sharing North America with early man 130,000 years ago? The answer may lie in the position of the bones and tools found at the site.
There are anomalous fragments of rock, anomalous fragments of tooth enamel scattered throughout the site that just don't make sense.
Could these stones amongst ancient bone remnants have been an early form of primitive tools?
And we felt that it was important to produce a map where we carefully plotted or precisely plotted the position of all the bones and the stones or whatever else is in there, so that we can understand what the general pattern is.
It's thought that the tools found with the mastodon bones were used for butchering the animal.
So this is one of the cobbles that we hypothesized was used as a hammerstone 130,000 years ago, where there was a carcass of a mastodon. These people were trying to recover raw materials from it. They had a problem. How do we break these bones? They look over into the active river channel, find some cobbles of the appropriate size and weight, bring them back to the site. And if you look closely, there's some striations coming off of that are indications of where this flake has come off.
The cuts in this rock led the San Diego team to conclude that these were actually tools used by humans. An idea that Demir says might not be so far-fetched. Dr. Stephen Holen is co-director of the Center for American Paleolithic Research in South Dakota. He was part of the team that evaluated the findings from the San Diego excavation site.
So what do we got in here, Steve?
Looks like vertebra.
That does.
I said, I can't get my mind around this. This site has to be really, really old. But yep, here's evidence of humans. I said it goes against everything I thought I knew and everything I have ever been taught.
Holland evaluated the mastodon bones and the stone tools recovered from the excavation site.
We would take the drawers out of the cabinets in here and bring them in on this table and look through them, paleontologists and archaeologists together. Richard Cerruti came in, so there were 4 of us, my wife Kathleen, Tom, and I, and we would look through and we would look for these very diagnostic pieces. And one of the things that we got all excited about first were these cone flakes that form in a circle around the point of impact from the hammerstone. And based on the experiment that we'd done in Africa, breaking an elephant femur with a big hammer, we saw the same kinds of fracture patterns that we did experimentally.
Holland specializes in evaluating broken bones at archaeological sites, looking for human causes, as this video shows from a test he conducted in Africa 2 years prior to working on the San Diego project.
Oh my God. As we puzzled over this, we kept coming back to this one explanation that explains all the data, was that humans did this.
The detective work by the San Diego Natural History Museum team was capped by the age dating that Richard Cerruti had done to prove the age of the mastodon bones he discovered.
This is one of the specimens that he used in his analysis. He cored it and he also sliced it. And after analyzing over 100 microsamples from this specimen and 2 other specimens of bone from the site, yielded an age of 130,000 plus or minus 9,000.
So after the article came out, there has been no critic come out to say that the dating is incorrect. In fact, other specialists in uranium series dating have come out and said the dates look perfectly good. So we're very comfortable with the dates.
While humans' arrival in the Americas may have occurred earlier than previously thought, new dating of another paleontological find, found in a South African cave, could soon upend long-held theories about the evolutionary tree of primates and early humans.
When we actually got into the chamber and could start removing it, we realized that not only was there one individual lying there on the surface, but the floor was literally comprised of Homo naledi. There are thousands and thousands and thousands of remains down in those chambers, and all you have to do is sweep the surface off, and there they are.
So the first time I sort of slid through that hallway into the open area where the chamber is and sort of started looking around, you know, you're only wearing a headlamp, so you just see flashes. But every flash of my headlamp showed bone. So I think right at that point I realized that we had a lot more than the original photographs actually had portrayed. So that was pretty exciting.
Homo naledi isn't really similar to any known hominid species in its entirety of its package. You've got little bits and pieces of almost everything we've ever found. Parts of the skull, if you just look at it quickly, look a little bit like Homo erectus. Got a very small brain. Other parts of the skull look very modern, like Homo sapiens. It gets stranger and stranger as you move down the body. You get the ape-like shoulders. You get these more and more human-like arms, which end with a hand that's human proportion.
I was actually at the London Natural History Museum, and Homo naledi was on the wall, and then there was estimated age between 1.2 and 1.8 million years. But then, when we actually did the scientific dating of those teeth, this is when things got very interesting, because then we got an age of 200 to 300,000 years old.
When we got a date, it was much younger than that, 250,000 years, give or take, we realized that we were dealing with a primitive creature, almost like a time traveler, that had come down from deep times to a point where it is very possible that Homo naledi was in direct contact with the emergence of modern humans. We never thought that was possible in Africa. Until this moment, we thought that there was effectively, during that entire time period of the Middle Pleistocene, late Middle Pleistocene, one form, a big-brained form of Homo sapiens. Now there are 2. And that adds incredible complexity to our record.
The world of Homo naledi and other early humans was different than it is today. A veritable Garden of Eden, teeming with life. Pure and free from pollution. Few places like this still exist, and most of them quite remote. But look just a few feet underwater and you can find one of the most productive and overlooked ecosystems on Earth. Scientists recently learned that seagrass meadows help scrub the surrounding water clean of bacteria from raw sewage and other pathogens. A recent study of polluted waters in Indonesia showed levels of harmful bacteria to be 50% less in spots with robust seagrass beds, leading to healthier fish and coral in the surrounding area. You see, seagrasses oxygenate the water, trap sediment that might otherwise float freely, and host tiny microbes that kill many harmful bacteria. Eliminating toxins improves the health of any system, and the workings of a human body is no different. In athletics, though, they say no pain, no gain. A nod to the physical effort required to increase endurance and enjoy the health benefits of exercise. But new pharmaceutical research also aims to make those benefits more easily accessible.
The potential benefit of a drug that can tune you up in the way in which you normally get tuned up by exercise could have really dramatic effects.
Playfully known as the exercise pill, the experimental drug shifts metabolism by triggering genetic instructions for the body to burn fat instead of sugar during exercise, something that doesn't normally happen until after extensive training and conditioning. Recent tests increased the endurance of otherwise sedentary mice, which also proved to be resistant to weight gain while on the drug.
We have two groups of mice, and one group on the drug, the other group as a control without the treatment of the drug. So we were quite surprised to see the astonishing results. The mice treated with the drug, they can run almost 100 minutes longer than the one that are not treated. The increase was around 70%.
Researchers ultimately hope their product can improve the health of the disabled, elderly, and obese.
There are many reasons why people can't either walk or run or exercise. And the idea is if you could bring a small molecule into the picture that can confer the benefits of fitness without training, you could really help a lot of people.
From energizing our bodies to powering societies.
So we are just waiting for the next experiment. It's going to happen in 10 seconds. There you go. You see the flickering of the plasma? We are creating fusion here. This is our little sun. It's extremely hot.
Each day, every 20 minutes, researchers build the sun. At the Culham Fusion Centre in Oxfordshire, Britain, generating temperatures greater than 200 million degrees, these nuclear fusion trials would be impossible without JET, the Joint European Torus, a donut-shaped plasma containment vessel.
At this point, we're the most important experiment in the world.
Thanks to JET, where energy is created by combining hydrogen atoms.
Right? There's heavy hydrogen, which we call deuterium, and the super heavy hydrogen, which we call tritium. And when they're running around at these temperatures like 200 million degrees, they bang into each other with immense speed. And when they do, and they get close enough, what we call the strong force, which binds the nucleus of atoms together, grips them, pulls them together, and they fuse, and they make helium, and they spit out a neutron. Fusion really is the perfect way to make energy.
And yet, despite fusion's transformative potential to provide safe and sustainable energy to the world, the program faces an uncertain future. While the British government committed to pay for its share of the experiments up to the year 2020, Brexit, its planned departure from the European Union, may also lead to the UK's withdrawal from scientific agencies like Euratom, the European Atomic Energy Community. Some say this could jeopardize jet logistics and operations, and perhaps also the larger next-generation fusion experiment, currently being built in southern France. If fusion represents harnessing the physical power of the sun, a moment of darkness reflected its emotional power. An awe-induced euphoria experienced by millions as the first total solar eclipse over North America in 3 decades made its way across the United States.
It's the most unnatural natural phenomenon I ever saw.
This is a solar eclipse, and just what people witnessed on August 21st along a 70-mile wide path. First along the Oregon coast at 10:15 a.m. Pacific Daylight Time, and last in South Carolina 94 minutes later. The uncommon coupling was the most viewed and photographed eclipse ever recorded. And yet, even as the sun re-emerged from the moon's shadow, some earthly domains remained, as always, far removed from its rays. Like the cave chambers, 300 meters below Mexico's Nica mine, enormous razor-sharp crystals dwarf human explorers. While today the cave is totally submerged, previous expeditions collected bizarre life forms from these crystal giants. They call this place Hell on Earth. Temperatures climb to 135 degrees Fahrenheit, with over 80% humidity. Even with life-saving bodysuits, no visit can safely last longer than a half hour. Yet deep within this extreme environment are life forms which exist nowhere else, known as extremophiles. NASA astrobiologist Penny Boston and her team found 40 strains of mineral-eating organisms. Trapped within the crystals here, they collected sample microbes, some dormant, but alive, estimated to be between 10 and 50,000 years old, including genetically unique and previously undiscovered life forms.
Any extremophile system that we're studying actually, allows us to push the envelope of life further. And we add it to this atlas of possibilities that we can apply to different planetary settings.
By expanding the definitions of life on Earth and where to find it, Boston's findings could impact the search for life beyond Earth. On places like the protoplanet Ceres, the largest object located within the solar system's asteroid belt, and one of the scientific targets of NASA's Dawn space probe. And in February of 2017, startling and unexpected news began coming in.
My colleague found a spectral signature in her data that is consistent with, or the same signature of aliphatic hydrocarbons. So here we're finding maybe the building blocks of biological material.
Seen here in red, the organic materials are thought to have originated in the dwarf planet itself. Dawn's study of Ceres also revealed evidence of water and volcanic activity, further raising the scientific profile of Ceres, no longer considered a barren rock. However, Dawn isn't the only NASA spacecraft uncovering new surprises about our solar system. Seven months after arriving in Jupiter's planetary system, the Juno Explorer became fully operational in February of 2017. Astonishing researchers with the steady stream of images and scientific data it's sending back to Earth. Jupiter is by far the largest planet in our solar system, leaving Juno with a whole lot of ground to cover. And although it is the second brightest planet in our night sky, its formation and composition have left us in the dark. Previous NASA missions have given us some understandings of its moons, small dust rings, and atmosphere. But we've not been able to see past the Van Gogh-like swirls of dense red, brown, yellow, and white clouds that paint the planet. At least, not until now. Each individual image is awe-inspiring, especially those captured when Juno came within 5,000 miles of Jupiter's Great Red Spot, the planet's most famous storm. Poring over data from Juno's microwave radiometer, scientists hope to learn more about what powers the tempest and how it differs from other Jovian storms. This critical instrument measures 6 distinct ranges of thermal radiation as it peers more than 300 miles beneath Jupiter's clouds to create a three-dimensional model of Jupiter's atmospheric environment.
So the first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different.
Current modeling estimates that the cloud cover is roughly 30 miles thick. Below it, there lies a 13,000-mile layer of swirling hydrogen and helium that changes states from gas to liquid as it nears the center, leading to a 24,000-mile deep sea of metallic hydrogen.
And if we can probe it and work out the abundance of elements in it, hydrogen, helium, the higher elements as well, and work out roughly what that mix is, it'll tell us something about not only how Jupiter was formed, but how the solar system might form.
If there is a bunch of rocky material in the center of Jupiter, it means that in the early solar system, before Jupiter formed, that rocky substances were probably coming together and Jupiter got built around those. It could be that Jupiter was built without any of those and that it just collapsed sort of like the sun and there is no rocky material or core of heavy elements in the center.
Strangely though, gravity data collected so far points to a new possibility. A somewhat larger than previously thought and perhaps partially dissolved core, leaving Jupiter experts with more questions than answers.
We're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet.
Juno's primary mission is scheduled to continue until February 2018. But this past year, NASA saw another of its extraordinary explorers come to the end.
And we are in the atmosphere.
As the Cassini space probe plummeted into Saturn's atmosphere in a fiery death spiral.
Roughly 1 minute to loss of signal.
The culmination of the craft's revolutionary scientific quest.
Call loss of signal at 115546.
The signal from the spacecraft is gone. Congratulations to you all. This has been an incredible spacecraft, and you're all an incredible team.
She has rewritten the textbooks about Saturn, the rings, the moons, Titan. So many things have changed because of Cassini.
From its launch 20 years ago to its bold grand finale, the Cassini-Huygens mission has unveiled some amazing discoveries. Saturn is ablaze with storms of unimaginable force. The place crackled with giant lightning strikes.